We're on lesson 3 of chapter 3, which is on scientific notation. We're going to learn to convert scientific notation to standard notation. We'll do standard notation to scientific notation, the other way around, and then a real-world application. First, what is scientific notation? First, let's remind ourselves what exponents are. We have 10 to the third. 10 to the third is the same thing as 10 times 10 times 10. 10 to the negative third is 1 over 10 times 10 times 10, so the opposite of this. So what people have figured out here is that they can multiply times 10 to the third and multiply a number times 10 three times. For example, if we multiply just by 110, this 3.0 turns into a 30. See how simple of a change that was? All you had to do was move that decimal to the right once, and now we have 30 instead of 3.0 when you multiply times 10. They also found out that when you multiply times the negative, it does the opposite effect. It's putting this over the 10 times 10 times 10, or however many you have. So if we do 3.0 times 10 to the negative first, it moves that decimal over the other way. So it's 0.3 now. So it does that opposite effect. So the great thing that comes out of this is that we can multiply any number times 10 to any power, and that'll tell you how many times to move that decimal over. So if we did this to the negative fourth power, we'd move that decimal left 4 times. 1, 2, 3, 4, and then you get your number. Here's your decimal, 0, 0, 0, 3. That comes from multiplying it times 10 to the negative fourth power. So let's do this here. So when we multiply times 10 to the ninth, it's really like multiplying 3.12 times 10 times 10 times 10, 9 times. And as you can see, I'm already losing track. It's easy to lose track of how many times you're multiplying times 10. But the simple fix is always just to move that decimal over many times. So I'm going to draw a lot of zeros in here, and let's move that decimal over 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's my new number. How many zeros? 1, 2, 3, 4, 5, 6, 7, and then 312 in front of that. So here'd be my new number, 312, and then 7 zeros. And then we put commas in to make it a good number. So that would turn into 3,120,000,000, and then less the zeros. It also works backwards then. When we do 1.35 times 10 to the negative fourth, just like this one, we move the decimal to the left. Here we move the decimal to the left this way. So we move it to the left 4. So let's move that to the left. 1, 2, 3, 4. Here's my decimal. Okay, and then we have empty spaces here which we could fill with zeros. 1, 2, 3 zeros. So we have 0.000135. So let's write that for our answer. 0.000135. So here's our new answer from multiplying times 10 to the negative fourth. Now we need to go backward. Let's turn standard notation to scientific notation. So we have 0.000403 in scientific notation. Whenever you move that decimal over, you notice that we had 3.12, 1.35. You always want to have one whole number to the left of the decimal. Only one. Not 0, not 2, 1. So we want to get the 4 to be that one number to the left of the decimal. So how many times do we have to move that decimal over? 1, 2, 3, 4, 5 times it took us. So we have 4.03. And then how many times would we have to go backwards to get to our real number here? Let's find out. 1, 2, 3, 4, 5. So we'd have to go negative 5 times 10 to the negative 5 to get back to that spot. So if we're going to represent this number, it would be 4.03 times 10 to the negative fifth. Here we have 42 million in scientific notation. We want to get 4.2 for our number. So how do we do that? Move it over this many times. 2, 3, 4, 5, 6, 7. All right, so it'd be a 4.2 times 10, and that'd be to the 7th power. If you want to check your work, you can go backwards and see if it comes out to it. A monarch butterfly has an average mass of 0.5 grams. In one roosting colony of Mexico, it was estimated that there were 10 million monarch butterflies. Write the total mass in scientific notation. So we have 10 million with a lot of zeros times 0.5. Well, I know times 0.5 just cuts it in half, right? But we can calculate this. 10 million times 0.5. That gives us 5 million. So 5 with 6 zeros behind it. So we need to turn this into scientific notation. It's way too big of a number. So what we do is we take the decimal. How many times do we move it over to get it to 5? 2, 3, 4, 5, 6 times, right? So we would say 5. You can do 5.0 or just 5. 5 times 10 to the 6th. So if you actually do this out, let's check our work. 5 times 10 to the 6th, so 5.0. Let's check it out to see if we're right. 1, 2, 3, 4, 5, 6. Let's draw zeros. Here's 1, 2, 3, 4, 5. Now let's see if that's correct. And there it is. There's the 5 million. So this does work backwards and forwards.